谢主办方的邀请。
I want to give my thanks to the organizer of the meeting. I'm from Bluepha Company Limited. Well, today, my topic is synthetic biology empowered by Industry 4.0. So what I'm going to talk about is I'm going to share with you on some of the experiences we have in a successful R&D. In the morning session, Dr. Zhou Min talked about product type of company as well as the platform type of company for Bluepha. And basically, we do is we produce the degradable and environment-friendly materials. And today, our business has been commercialized. At the same time, during the process of R&D, we also have met some really good platform. So I should say, we are also a platform company. That's why we cover ourselves as a T-shaped company. We have a R&D platform. We also produce our products in our pipelines. So when we look at synthetic biology, very often we always compare that to electronics engineering, because for double E, basically, you just manipulate all those electronic components, as well as those modules, and you form a terminal finally, and it could establish a network. So basically, for synthetic biology, we just control all the basic or the fundamental proteins to make sure that they could have some kind of reactions. Finally, E could be functional in certain ways, and through this synthetic process, it could realize the biological function we expect. But during the process of industrialization, synthetic biology still faces new challenges, although it has a history of 20 years. From process development to optimized production on industry and scale, we should say, when we talk about strengths, this is only the starting point. And after that, it needs to go through for scale enlargement and manufacturing, etc. In the production phase, it may face challenges like contamination and non-controllable challenges. And during the process of extraction, to make sure our product become more competitive, we need to make sure that our purification process can be efficient. So all these challenges have been dealt with by us. So today, Bluepha designed and built a bio and OS, synthetic biology and R&D infrastructure. In the past, we have been talking about Industry 4.0, that's about automation. And today, by using SynBio and OS, it has greatly empowered the R&D for biology and products. So it plays a role as a stream platform and process and platform. Everything could be digitalized. So next, I'm going to give you some details on the modules on our platform. So first, I want to talk about the BioCOD.
Well, this is a cloud design and software. BioCAD
And we believe that this is the first in China which can have automatic design of the biosystem and also confirmation. We really have the Ministry of Science and Technology program. It is a graphic, very easily to be used. It have a automatic error correction function. In R&D process, there are a lot of process data generated, including our experience. And we know that the biosynthesis technology after 2 decades of development, there are a lot of the components be accumulated, whether internal or external knowledge, how to integrate it, how to have a repetitive use. This is the question. We have a code base. This is a synthetic biology knowledge database. For this database, we integrate our own database as well as an external bio database so as to guide us and empower us and to do the string design. And next is auto build. It's an automated string construction platform. As you know, for the string construction, especially industry-oriented string construction, the throughput is the bottleneck. For the traditional lab, it's manual. The throughput is limited. The accuracy is not enough. And after the string construction, you still have to do the high throughput screening. The throughput during the screening is also another bottleneck. For auto build, on one hand, we have automation, the molecular cloning to the string construction and automation operation, etc. Every step has been automated. We also have the dark lab platform. So for this dark lab, from the string cultivation to high throughput, the growth test, and also production output and measurement. These can have automated operation 7/24 unmanned, unattended operation. It can achieve the thousands of the strain screening throughput, give a great empowerment to the upstream R&D. So after strain constructed, after early screening, before the implementation, we also need to go through the pilot test. Traditionally, some universities, maybe at the string construction, they have very good throughput, but before the application, they have another bottleneck. This one is the pilot bottleneck. We have the auto farm. This is the high throughput, the automated reaction array. It can really liberate human labor. This reactor is also self-designed with higher robustness and stability. Now, we also have our proprietary IP. And we have a cyber farm digitalized fermentation cloud system. And this system, in the fermentation, it can collect the multidimensional fermentation data, and so as to achieve a remote control. So the palate screening is more intelligent. So on the whole, you can see this is the Symbiosis platform. The platform has successfully improved the efficiency of the string R&D. Internally, the iteration has been greatly enhanced in the very early days, and we have 3 years for one string iteration. But now only need half a year for that one string iteration. The digitalized reactor, bioreactor array from the 500 ml and to 200 liter, and they will have a various kind of different size reactor. So we have different volume. The test barrier has been set up. So we have the global leading the R&D research barrier set up. So on the whole, by Symbiosis platform, we have successfully expanded the synthetic biology R&D from lab to fab. Inside the lab, we will be able to construct a strain quickly, and also in the real production, in the industry application, we'll be able to bring the industry data back to the lab. So have the DPTL loop from the lab to fab and the fab to lab for our company. And then PHA. PHA is a natural biodegradable polymer. PHA is a larger group of the molecular. We have PHBH in mass production already. Our PHA product, the advantage of it is under all the circumstances in the environment, it is naturally degradable. So here you see this animation about the PHA straw. So in soil or in natural water environment, it degraded compared with the market available material. Our PHA in environment can be degraded fully within a couple of months. These pictures show from the fermentation and to the end of fermentation. Within the field, there is a process of accumulation of PHA. You see that the cyst gets bigger, and inside the cyst, they are the PHA, and also the output is getting higher. By our Symbiosis platform, we have successfully a self-proprietary technology called bihybrid. By using it is really innovative breakthrough manufacturing technology, combines CO2 with a biomass as a feedstock to produce Bluepha PHA. By hybrid technology, greatly enhance our PHA production output. At the same time, it is really very meaningful because it's a low carbon production. In addition to the food carbon source, we also use the biomass leftover, like left cooking oil and other waste material for the pilot program. We have our plant located in Yancheng, Jiangsu province. The first phase capacity is 5,000 tons already in mass production. We have a plan in the coming years to further expand our capacity. The total capacity will be 25,000 tons. In the future, we are going to further expand the capacity to 100,000 tons. Okay, this is about the presentation. Thank you very much. Well, thank you very much.